here we have T1, T2, here we have T3, T4, we have T5 here, and finally the switch T6. From here, this is T1, this is T2 here, this is T3, this is T6, this is T4, and this is T5. So now we have here each switch will conduct for 180-degree conduction. So 1, 2, here we have a 3, we have 4, we have 5, we have 6, and we have 7 for the last year. So here the first T1 will conduct for 180 degrees. This is 60 degrees. This is 120 degrees. This is 180 degrees. So T1 will conduct for here. T1 will conduct for 180 degree conduction, which is pi here. This is pi. This is pi. This is 240 degrees. This one is 300 degrees. This is 360 degrees. This is 2 pi here. So now the first T will conduct for the first 180 degrees. The second one will start after 60 degree distance here. So which conduct is for 180 degree here. This is for 180 degree T2. Again T3 will conduct after 120 degree distance, which means after 60 degree. From here it skips to here 120 degree, which means 60 degree. From here, which is 60 degree, from this, which is 60 degree here. So this will conduct for 180 degree here. Look here. T4 will conduct again for 180 degree. T5 will conduct here. T5 will conduct here, which skips in here, and then it conduct for 120 degree. Then it is the remaining 60 degree will back to here, and which conduct for 180 degrees. So this is 60 and 60, which is 60 degree plus 60 degree, which is 120 degree. Here I have a 60 degree, which is, so 120 plus 60 degree, which is equivalent to 180 degrees. So for 180 degree conduction, this is here, and the last T6 will conduct in here, which skips in here and back to here. The remaining 120 degree conduction is, so here we have 60 degree, here we have 120 degree. So 60 degree plus 120 degree, which is equivalent to 180 degree. So now let us draw our switching pattern from here. So look at here. The first T1 will conduct in the first 60 degree, because the switching pattern will draw in every 60 degree. In every 60 degree, for the first 60 degree, look at here, T1 will conduct, T5 will conduct, and T6 will conduct. So for the first 60 degree, we have T1, T5, and T6. This is for the second 120 degree. Look at here, T1, T2, and T6, which is T1, T2, T6. For the surge, 180 degree, 180 degree. Look at here, T1, again T2, T3. The remaining are 0 here. So T1, T2, T3. What about the surge? The surge, we have no T1 here. We have only T2 here and T3, T4. So for 240 degree here, we have T2, we have T3, and T4. Alright, okay. Okay, the next 300 degree. 300 degree, look at here. We don't have T1 and T2 here. We have only T3, T4, and T5. We have T3, we have T4, we have T5. For the last 360 degree conduction, our switching pattern will look at here. We don't have here T1, T2, T1, T2, T3. We don't have T1, T2, T3. We have only T4, T5, and T6. We have T4, T5, and T6. Therefore, from this, the switching pattern sequence will be like that. Let us see in here. So in here, the switching pattern sequence will be like T1, T5, T5, T6, then we have T1, T2, T6, then we have T1, T2, T3, then we have T2, T3, T4, T2, T3, T4, then we have T3, T4, T5, T3, T4, T5, and finally we have T4, T5, and T6, T4, T5, and T6. So from here, our switching pattern looks like this. Switching pattern looks like this. So this is all about our today's lecture in power electronics switching device, especially 3-phase pull bridge inverter at 180 degree control conduction. So thank you. Don't forget to like, share, and subscribe. See you in the next. Bye bye.